Here we go. Scatter plots. Scatter plots really are not that difficult. What it is taking a coordinate. So you have a coordinate, let's say like this, of 1, 2. And you would plot that on a graph. You would take a graph and you'd plot that point. So my x is 1, my y is 2. There would be a point that I'd plot on that graph. And after you plot a series of points, you could or could not get a relationship that starts to happen. If you take a look at this graph right here, you notice which way do the plots go? They go up. They go up at an angle like this, right? They go up like this. And really, to do it correctly, let me redraw that line, because you want to kind of split it right in the middle of where this line is going. All right? So it looks something maybe like this. And then from that, you can literally create an equation. All right? If I wanted to put create an equation for this, I can do this. All right? Just by knowing, number one, where does it cross the y-axis? What is my slope? What's my slope here? Well, whatever it might be, you know, we can figure out what our slope is. We can figure out where it crosses the y-axis. What can we use? Slope-intercept form, right? We know where it crosses the y-axis. We know what the slope is. We can make an equation from that. How about this one? What is the relation on this one? Down. It's a down. It's down this way. All right? How about this one? Down. Is it? It's kind of all over, isn't it? It's kind of everywhere. We really can't make a correlation between that one. This just happens to be a mess. And there's no correlation to it. All right? That's how we can do scatter plots. So let's say we took something that was in business, logging, all right? And we went out and we said on Mondays, we typically haul this much wood. On Tuesdays, we typically haul this much wood. On Wednesdays, this much. And we plotted that all out. And we took a look. Is there any correlation that we can find at how, maybe as the week goes on, we haul more wood. Maybe as the week goes on, it's about the same. Maybe as the week goes on, it declines. We can use that correlation to kind of predict what our next week's going to be, or maybe the week after, or maybe if we do it for a month, we can predict what's going to happen in business. We might turn around and do a whole year's worth and be able to say, no, answer me this, Fletcher. Does the logging business go up and down during different parts of the year? It does, can't you? And I bet you can. It goes down. You can predict what's happening. Now, you know this because you've been with the business long enough that you see that. But if you wanted to show somebody that doesn't know anything about logging what happens, you could do a scatter plot of the amount of wood that's being hauled, and maybe in weight, and watch how in the summertime it dips. But then as fall comes, it starts to pick up again. And in wintertime, it goes way up. And then as you get into spring, it starts to dip again and comes down. You can plot that out for somebody. So here a guy comes in. He's investing big money in your operation. And he says, I want to know what to expect for the year. You could come in with a scatter plot graph for him based on month and the amount of weight, let's say by week, you're doing it. So you could do it out to 52 weeks. And you can show this investor, this is what you should expect. This is how our year is going to go. Okay? That's how scatter plots can be used. It uses to predict. It uses it to estimate what's going to happen. It uses to tell a story, all right, of what's going on. So if we took, let's look down here. All right, we've got, in this case, it's a table. It shows nutritional data, different types of pizza. Make a scatter plot of the data. How would you describe the correlation? Okay, we've got the type, we got cheese, pepperoni, veggie, Mexican, Hawaiian, barbecue chicken, and the works. It shows the number of calories per slice on each one of these. Okay? And it also shows the calories of fat on each one of these. So if we're taking a look at a piece of pizza, a slice of pizza, we know how many calories we got it. We know how many of those calories are fat. And if we want to really take a look at the nutritional value of that slice of pizza, we're going to be interested in this, right? More calories, is it more fat? We got to take a look at that depending on the pieces of pizza. So if we drew a scatter plot on that, we would draw it out something like this. We would have maybe the total number of calories here, and then the fat here, calories. And we would plot this out. We know that our calories here is 272. Let's say it's right there, but our calories of fat is 88. So it would, we'd plot that maybe right here. That'd be our point. And then we go to the next one. We're up to 298, and we're up to 109. Maybe the next one is up here. Okay, and we plot each one of these points out. We would be able to determine, depending on this, we would get a scatter plot. Actually, it looks like they got one right here. We could get a scatter plot of that pizza. Now, here's the question. Can I determine that as the total, well, here they went calories of fat. They went opposite of me, and this is per slice. Can we determine that as the calories for the slice go up, that the fat goes up? Look at our line. We can. We can determine that as the amount of calories for each slice goes up, the amount of calories of fat goes up as well. All right? That's kind of big. Then we look at it and say, well, how do we do nutrition? Do we need to have a pizza? If we're looking at number of calories here, which one is the least on here? Hawaiian, right? 160 calories. Maybe instead of eating pepperoni, if we ate a Hawaiian pizza, we'd get just as full. But we wouldn't be putting that as much calories into our body. All right, of fat. So maybe that's more nutritional. Because there is a correlation here of number of calories to how much fat you have in it. So that's how we can turn around and use a scatter plot to really determine what we should be doing. All right, it's a predictor. It's an information thing. It gathers information for you, and it can tell you what's happening. All right. Now for 1 and 2 on this, and you guys are going to be doing all of these. There aren't many problems. You're going to make a scatter plot. All right. You're going to use. You can get some graphing paper back here if you want. You're going to make a scatter plot, and you're going to determine what is the correlation that's happening. Is there a correlation? If there is, what is it? Is it an up? Is it a down? Is it nothing at all? All right? That's the first part. Oh, man. I have never heard so much whining in my entire life. Whine, cry, wah. All right. Let's take a look at this. U.S. data in a table, draw a scatter plot and a trend. If the trend continues, about how many billions of dollars will the U.S. spend in health expenditures in 2015? So now we're going to go into a prediction phase. Now we're going to turn around and say, okay, this is what our current data is. If it continues at this rate, do you think that's what they're doing with like the national debt? What they're trying to do with what they call climate change? They're using this. Now I'll caution you. The numbers they use, are they correct? All right, are they one of the things with climate change, and I'll just throw this out real quick. Here's the big problem with climate change. They say that our CO2 emissions are going up and that, all this stuff is happening, but when they turn around and do the calculations, they're doing it wrong. And if they turn around and they do the calculations right, in other words, they're assuming this much CO2 emissions, which isn't right, it's actually gone down or stayed stable, then you would find that we're actually stable. Everything is not changing. It's just Earth. All right. So here's the crux of this. Yes, you can determine, but you have to make sure the data you're using is factual and accurate. Okay? But in this case here, we can take a look, and if you have very straight numbers, it says expenditures in billions of dollars. This is how much they spent, number of years since 2000, and they can turn around and say in 2000 we had 1.34, actually that would be trillions, billions of dollars. This would be trillions. So 1.345 trillion dollars. 2002 we had 1603, 2004 1852, 2006 2105. If we were to plot this out and draw our line here, I hate it when it happens, and draw our line here, we should be able to take a look out here, and they're saying out in 2015 is somewhere out here, right? Right? It's wherever they got their dot. It would go up to here. Where would our expenditures be? Well, they're predicting, over $4 trillion a year. That's a predictor in being able to figure it. Well, actually, right here, model predicts 3,200. So I'm off down here somewhere. This is 2000. Well, this is a number of years. Okay, we're looking 15 years. So 15 years is here, and we go up to right up there. Okay, that would be our line up. In 15 years, it would be 3,200. All right, that's a predictor. We can predict based on previous data using a scatter plot. That's what you're going to do on this side of the sheet, is you're going to predict. It says here's our total U.S. population enrolled in Medicare. All right? Draw a scatter plot. What would your scatter plot be in this case? Well, we've got the population would be one side of the scatter plot, maybe your y-axis, and the population in, do we want to do years? Yes. They want to know, use the data table, draw a trend line to write the expectation, use your model to predict the number of Medicare enrollees by 2015. So, one of them would be, what do they got? Oh, this is, I see what they did here. They got this here. They got it broken up two different places. So this is here, and then this is here. And if you take a look, it goes from 2000, 2001, 2002, then over here 2003, 2004, 2005. So you actually get six plots. You got the year, and that may be, you may do something like this. You may make this year and this population, okay? Medicare over here. And you graph it out. Now, if you noticed on this graph up here, notice they didn't go by ones. When you go up this way, you may go 2000, then 2001. But this way, you may start out at, oh, look at where your graph's at. 39.7 is the lowest. I may start this at 40, right? And then go out to here to, well, they're only going up small increments. I may make that 41, then 42, all right, and on up. And then you predict that by the year 2015, is it? Yes, up here somewhere would be 2015. Where does that meet up in here? Where is that? And that'll be a predictor to tell you about how many people will be on Medicare. All right? See how to use scatter plots? See how to use scatter plots? I'm surfing. All right? None of that stuff, huh?